State Gauss law for magnetism. Explain its significance. Gauss law for magnetism states that the total flux of the magnetic field through any closed surface is always zero. This law implies the magnetic manifolds do not exist. Magnetic field lines form closed loops. Write the four important properties of the magnetic field lines due to Bohr magnet. Properties of the magnetic field lines are: magnetic field lines always form continuous closed loops. The tangent to the magnetic field line at a given point represents the direction of the net magnetic field at that point. The larger the number of field lines crossing per unit area, the stronger is the magnitude of the magnetic field. The last one, magnetic field lines do not intersect. These are some of the important properties of the magnetic field lines due to a Bohr magnet. Second part, write 3 points of difference between paramagnet, dia and ferromagnetic materials. Give an example for each. The different differences is, for example, diamagnetic, the X value it is a range between it is greater than or equal to -1 and it is less than 0. And the paramagnetic value, it is greater than -0 and less than epsilon. And the ferromagnetic, it is greater than or equal to 1. And the mu r value in the diamagnetic, it is greater than or equal to 0 and it is less than 1. And in the paramagnetic, it is greater than or equal to 1 but less than 1 plus epsilon. And in the ferromagnetic, it is greater than 1. And in diamagnetic, mu value, it is less than mu naught. And the paramagnetic, it is greater than mu naught. And the ferromagnetic, it is greater than mu naught. Examples of the magnetic, that is the diamagnetic materials are, we can take bismuth, copper, lead, silicon, water, NaCl, nitrogen. At all these are at a standard temperature and pressure. For paramagnetic materials like aluminium, sodium, calcium, oxygen, all these materials also in a standard temperature and pressure. For ferromagnetic materials, examples like iron, nickel and cobalt. These are some of the examples for the diamagnetic, paramagnetic and ferromagnetic materials.